Good morning, everybody. I'm just waiting for slides to get queued up here. My name is Joy Weiss. I'm the Vice President of IoT and Security Solutions at Analog Devices. And I'd like to take this opportunity to welcome you to Barcelona. And I'll be signing up for a $0 car right after this session. Can I get the slides queued up here? Oh, there we go. Sorry. Is it possible to see them on the PC or? Okay, I'll head out here. Sorry about that. I hope you enjoyed yesterday's Congress. I'm going to start the day today with a look at applications that really push the boundary of technology and system design that we like to call Extreme IoT. I'll tell you a bit about Analog Devices, and then explore a variety of applications that our customers are working on that really do force us as Analog Devices to be ahead of what's possible from an IoT technology and systems perspective. When this event occurred last year, I might have been talking to you as a linear technology employee. 5 years ago, I would have been here as the CEO of Dust Networks. But 2 acquisitions later, in a very rapidly changing world, I'm very, very proud to be here as part of Analog Devices. We have over a half a century of experience helping our customers solve the very hardest problems with a portfolio of solutions that leverage high-performance analog, mixed signal, and digital signal processing technologies, which includes ICs, algorithms, software, and subsystems. After all, IoT really does start with converting the physical world into the IT world. So bridging the analog and digital worlds is at the very heart of IoT. What gives us the credibility to talk about Extreme IoT? Well, we have a portfolio of more than 45,000 products serving 125,000 customers worldwide. We create the technologies to sense, measure, interpret, and connect IoT applications, and we're helping our customers build end-to-end solutions that secure data all the way from the sensor to the cloud. I've personally been involved in creating high-performance wireless networking technology for more than 14 years now. So I have seen a lot in my day. At Analog Devices, we strengthen our core technology both organically and through acquisition. With respect to IoT, we've invested in IoT sensing platforms such as Snap Sensors, Cypress for cybersecurity, which is now part of my team, Dust Networks for wireless networking, and Innovasic for industrial Ethernet. All of these teams are represented at the show here, both on our booth and in some of the test beds that you'll see. Our 2016 revenues combined between Analog Devices and linear technology were about $5 billion, and we're planning to spend about $1 billion in R&D this year in 45 design centers around the world, including one in Valencia here in Spain, to help our customers do what we call getting ahead of what's possible. More than 60% of our business is in the most demanding applications, such as industrial, automotive, and healthcare. And that's why I'm here today to talk to you about the challenges of these very demanding customers that they're trying to address in Extreme IoT. So let's try and frame out how we look at IoT. In its most basic form, IoT applications, we have sensors that will send data to the cloud for processing and analysis. Generally, the technology imperatives for basic IoT nodes requires low-power sensing and perhaps low-power wireless technology. If the sensor data is not too complex, if it's relatively small in terms of the bandwidth required, and if the delivery of data is not too time-sensitive, this model can be very efficient. But what if the data is a complex waveform? Oh, so large that it will take too much power to send it regularly? What if the operating environment is in the desert or the Arctic? What if the thing is a moving robot in a factory full of radio interference? We call this Extreme IoT. Extreme IoT calls for a level of precision, robustness, resilience, security, and accuracy under a very wide range of operating conditions. Extreme IoT applications typically require a systems-level approach to designing the end-to-end application with careful consideration of each element of the solution to perform and deliver trusted, timely, and accurate information at all times. These elements include precise sensing and measurement under the harshest conditions, low-power signal processing at the node, as well as the gateway, as well as the cloud, secure end-to-end connectivity, stringent safety considerations, and let's not forget that in many of these applications, the person either installing or using the technology has no knowledge of technology. They're not wireless experts, they're not electronics experts. And so fundamentally designing these complicated products for ease of use, ease of deployment, and ease of commissioning is critically important. But let's take this up a level from bubble diagrams. Why is IoT a megatrend? Because the ability to get information about things and act on that basis of that information is valuable. It makes our lives and our businesses more efficient, safer, greener, simpler. For a homeowner, the precision of a thermostat or of a temperature sensor in that thermostat can be off by a degree or two, and chances are that nobody will notice. The time it takes that temperature data to get to the furnace, if that's off a little bit, you can mitigate that from a systems perspective by going into your closet and getting out a sweater. But if you're in an oil refinery, even a tiny change in temperature or pressure at some point in that plant could make the difference between a safe situation and a dangerous situation for the personnel in the plant or for the neighborhood. Moreover, it can cost tens or even hundreds of thousands of dollars in lost productivity just for that minute change being sensed in a timely manner. Welcome to the world of Extreme IoT. So let's take a look at a couple of applications that we're working on with our customers. In the industrial world, Industry 4.0 is really a global phenomenon by now. Commonly referred to as industrial IoT, manufacturers are unlocking new levels of productivity and flexibility by connecting the internet to the industrial automation network. To enable this, we need intelligent sensors and control systems with secure connectivity. Industrial IoT is Extreme IoT. Hazardous environments are common, and electromagnetic interference can also be a major challenge in these applications. Wiring to power sensors and connect them may be impractical. For example, adding wired sensors to rotating equipment can be a non-starter. A wire-free option is key to enabling pervasive sensing for Industry 4.0. Another element that comes into play for industrial applications is the frequent need for time-sensitive or time-stamped data. Deterministic networking can enable control applications, and timestamp data can be used in algorithms that trend events across the factory that deepen the value of the information that's collected. You might want to stop by the time-sensitive networking testbed to learn more about this concept. But in these environments, safety and security is not on a sliding scale. There's a very high bar for both safety and security for industrial internet applications. Oh, sorry, I'm headed in the wrong direction here. So the imperatives from an extreme IoT perspective for industrial applications are flexibility, efficiency, safety, security, and robustness. So here's a real-world example of an extreme IoT application in a semiconductor fab environment. In a fab where semiconductor wafers are manufactured, there are specialty gases used in the production process. The collection of gas tank fill data is typically done using a technology I like to call SneakerNet. It's somebody walking around the plant in sneakers with a clipboard, manually looking at the fill levels on the tanks and writing that down. That process is very expensive. It takes almost 4 hours a day to monitor the 175 tanks in this plant. It's error-prone, and it doesn't allow for the planful replenishment of the critical gases in the plant. Enter Extreme IoT. The ability to do this continuously and remotely not only saves money, but it avoids unplanned downtime and reduces waste from early tank changes. The availability of this data electronically allows the fab operator to analyze trends in consumption and proactively plan capacity. As you can see, the fab is a sea of machine and pipes. The cost of wiring sensors is prohibitive, and in some areas in the fab, it's simply impractical. The ability to retrofit the built environment, whether it's in a semiconductor fab or a business building or any environment where you may want to introduce extreme IoT technology, requires no wires communications. Not just a wireless communication from a communications perspective, but in fact, communications that can happen for many years on very low-cost batteries so that power wires are not required either. And in this example, despite this very harsh environment, this sea of metal that we're operating in, this system runs 2 orders of magnitude better reliability than carrier-class communications that you would typically see in a telecommunications network. That's extreme IoT. Another emerging application in the industrial space is condition-based monitoring. Now, this isn't a new concept. Companies monitor critical assets at the heart of their operation to maximize their uptime. The information is used to predict and plan repairs versus allowing the plant to experience any kind of downtime. But historically, this has only been done on the most expensive assets in the plant, and it's been a very manual process typically. The extreme IoT version of condition-based monitoring allows us to continuously and automatically detect specific degradations in performance on more equipment cost-effectively. Wireless allows sensors to be deployed much more cost-effectively on more assets and less expensive assets, and this improves the coverage of the total system. However, in many, many cases, these critical assets are exposed to very wide extremes of temperature, moisture, vibration, and other factors that make getting precise measurements, which are necessary for the analytics, to be taken accurately. So the sensors and the whole signal chain in these applications must be designed contemplating these variables. Knowing that you have a problem is important information. Knowing why you have a problem is critical insight. Here's another real-world example in a semiconductor fab where the ability to quickly pinpoint the source of a problem in a motor is key. In this case, we need the ability to monitor smaller signals accurately inside the motor to determine out-of-range performance at the system level. So the size, cost, packaging, and power consumption of the sensor is also an enabler for extreme IoT. In this case, MEMS accelerometers with wider bandwidth and low noise allow smaller signals to be measured. This means faster, more accurate determination of out-of-range performance in a system. Instead of knowing that a motor is out of range, we can actually pinpoint the source to a damaged ball bearing if it's properly instrumented with the proper technology. So if it isn't challenging enough to operate under extreme IoT conditions, the game changes again when the things start to move. In fact, another complete dimension comes into play for extreme IoT, which is when the precision of the location of the thing is material to the application itself. So if you're wandering around the Rambla looking for the next place to have tapas, you can usually you might get there using Google Maps, but you can use visual cues to figure out where the restaurant may be. But if you're trying to maximize the crop yield while minimizing water consumption, you may need centimeter accuracy to know where your automated irrigation equipment needs to put water. So let's look at some of the specific challenges associated with the Internet of Things that move. Machines that move present new extremes that need to be considered. Multiple sensors may be taking measurements at a variety of precise locations, and the machine itself may be subjected to a pretty wide variety of conditions that make sensing, positioning, and communications that much more difficult. What may work in a fitness watch may not work in a surgical robot. The sensors on the moving thing may also be providing important context for the precision of the location determination. Accurately detecting when a thing is in motion or at rest may be the trigger for taking an important measurement as well, or material to the value of the sensed data. So extreme IoT also needs high-performance industrial sensors that can provide sub-degree pointing accuracy while maintaining precise geolocation under a very wide variety of conditions. Let's talk about another class of moving things in a fast-growing IoT market. Electronics are critical to next-generation automotive design. In fact, electronics will literally be driving our cars for us in the near future. But the safety of passengers is not a variable in the equation, and the transformation of the vehicle to a giant computer on wheels is forcing the industry to innovate extreme IoT solutions in the automotive world. Now, there are automotive applications that follow that more basic IoT tenet that we talked about before. For example, if traffic information is somewhat delayed or inaccurate to your navigation system, you may take a little longer to get where you're going, and even that system is pretty redundant. Likely you have your phone beside you and you can program in whatever you want, and that'll be your backup system. But there are applications, in particular those with safety ramifications, that require a whole new level of extreme system design. Let's look under the hood of a car and look at another extreme IoT example. Battery management systems, or BMS, measure the energy that goes in and out of a battery. And Analog Devices is the #1 provider of BMS chips to the electronic vehicle industry. BMS systems monitor the voltage and temperature and a couple of other aspects of the battery in order to assess the remaining energy and the state of charge and the state of health of the batteries. That BMS chip needs to provide precise, consistent data within an environment that is electrically noisy and very hot. It also has to provide very fine-grained data on internal module and system temperature measurements rather than just coarse data or broad brush aggregate values. But if the BMS data, this accurate data, is transmitted by wires and connectors, it turns out that becomes the very weakest part of the system and prone to mechanical failures. So what if we combine extreme IoT wireless technology with BMS? Well, it turns out it works pretty well. And we should know, we built one last year, and we drove it to the Electronica trade show in Munich. The wireless network not only mitigates the point of failure, it actually reduces the weight of the car and delivers built-in isolation from the spiky electrical environment that exists within the battery enclosure. And now that the battery pack is smart and can talk, because it's wirelessly enabled, the battery packs can easily be observed throughout their manufacturing process, during their life in your car, and in their second life, which may be as a storage device for some other application. All of this makes for safer, smarter, and greener cars, all hallmarks of extreme IoT. Here's another real-world example of IoT on a different kind of moving car, a rail car. We have several customers who deliver IoT solutions for rail applications. Deploying a wireless system on a moving freight car is deceptively challenging. Not only is it a great big metal box, but in fact, the reflections from the tracks and the changing climate around it makes it a particularly harsh environment. In this example, a variety of conditions on the rail car are being monitored for proactive maintenance, security, and safety analysis. Sensors are deployed at the bottom of the car to monitor the bearing temperature on the wheels of the car, and for various parameters on the side of the car, such as handbrake sensors, door open-close sensors, and in a refrigerated car, the temperature inside the car itself. This information is collected by a robust wireless system on the car to a gateway on the car, where the state of the sensors is analyzed at the edge to see if it's normal. To conserve energy and cost, the data is only transmitted via cellular or satellite if there's a condition that merits transmitting that information. Now, the growth in IoT has been mirrored by the growth in the number of wireless options there are to serve IoT applications, but not all networks are created equal. What may work for a thermostat in a home may not work on a moving rail car. As we've seen in the previous example, there are special challenges for wireless solutions in these very harsh, extreme IoT environments. It's a popular misconception that a radio specification will determine the performance of a wireless system. That's simply not true. A radio is an important and critical building block, but the network architecture and protocol can confer as much value in terms of the reliability, latency, performance of the system as the radio itself. In the smart battery example we looked at in the car, data has to be transferred synchronously, continuously, and within tens of milliseconds. In a smart grid application, for example, where meter data may be collected, once a day may be sufficient. In the semiconductor fab we looked at, battery life is extremely important. You don't want to be going out and having to change the batteries all the time, or you've created a new maintenance problem. In that environment, we get 8 years of battery life on that system, whereas a system that might be architected differently might run out of power in months or even days if improperly architected with the very same radio. Security is critically important in this environment as well. End-to-end security must be contemplated in the system design all the way from the hardware at the edge of the network right up through the cloud continuously. And these things must be married together. Security cannot be an afterthought in the design of connectivity from sensor to cloud for Extreme IoT. So let's take a look at one last real-world example in the world of agriculture. Here, IoT is being used to analyze extremes in weather and save a valuable crop. It turns out in 2013, frost caused more than $100 million in revenue loss to the peach farmers in Mendoza, Argentina. In the testbed area here, you'll be able to visit the team who are helping farmers to predict frost events by deploying a variety of sensors in peach orchards and analyzing time series data to predict frost events. This allows the farmers to deploy mitigation techniques in advance of those events to protect their cash crops. Tomorrow, my colleague Eric Olson will be on a panel talking in more depth about the system-level considerations and benefits of IoT applications for agriculture. So let's wrap up our overview of Extreme IoT. We've talked about a set of applications that call out for a very high bar of capabilities from the sensor to the cloud. These applications require thoughtful level system design considerations from start to finish. These include the most precise and secure data under the widest range of conditions, with low power processing at the edge and processing at the gateway and in the cloud, depending on the application requirements, reliably and securely connected to the cloud to fulfill the promise of the Internet of Things. We've spent the last half hour discussing a class of applications that really push the envelope for technology and systems. At Analog Devices, we're partnering with our customers to understand their needs from trusted sensor to cloud, and we're innovating with the bold goal of helping them to be ahead of what's possible. I'd like to thank you for your attention today and hope that you enjoy today's program at the Congress. We look forward to seeing you on our booth at tomorrow's panel and in the test beds where you'll find some of my colleagues and our partners showcasing extreme IoT capabilities. Thanks very much and enjoy your day.